What's up, everybody? This is page 400, and we're going to finish out this video for you. So, in order to be ready for today, we're also going to flip forward to page 420, because in there we had cut out the different criteria, the different characteristics of quadrilaterals, and glued them in. And so I went ahead and did all that. Let me go ahead and share with you let's actually reveal one little itty bit at a time, okay? So here it is. Let's see, a quadrilateral, right? This is all about quadrilaterals. And what we do here is eventually going to translate back to questions we'll answer on page 400. So a quadrilateral, it has four sides. I mean, that's literally in the name. Quad for four, and then lateral, which is a word for side. There are two diagonals. From quadrilaterals, they split into two different categories. And so those two different categories are trapezoids and kites. Now, a trapezoid has the condition that at least one pair of sides are parallel. In a kite, that's not a condition. In a kite, the condition here is that there are two pairs of congruent sides, but those sides are actually connected. Also, in a kite, the diagonals are perpendicular. So I put a little box right here. And if you would, please add this detail, the notation here. Add the markings around, like these angles are vertical angles, because when two lines cross, they create vertical angles. And then those are actually two pairs of congruent vertical angles. Same thing in a trapezoid, no difference. But the interesting thing about a kite is that these are all 90 degrees. And so there's a little box around the place where they cross. Extending trapezoids to isosceles trapezoids. So I got a label, a label, a label, and a label. In an isosceles trapezoid, it's really like an isosceles triangle, got the top cut off. And we create sides that are congruent, and they aren't the sides that are parallel. That's a different condition for our next quadrilateral. But these sides, the diagonals are congruent, is an isosceles trapezoid. And furthermore, extra angle marking there and extra angle marking there. Maybe 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. 1, 2, 3. So they still have congruent vertical angles, like, around, because vertical angles are congruent. But in this place where the diagonals cross, it does create a whole host of equal or congruent values that we could use. Coming up next on our list are parallelograms. And parallelograms, they're kind of like a specialized form of trapezoid. Like whatever this condition for a trapezoid is, with at least one pair of parallel sides, a parallelogram says, not just one, two pairs of parallel sides. And if I look forward at that, okay. So now that we have two pairs of parallel sides being the condition for a trapezoid, what else do we get? Well, we get opposite sides are congruent. So double spike, single spike, single spike. We get opposite angles are congruent. So one angle marker there to the other corner on the opposite side, that angle congruent. Double angle marker there. So that tells us opposite angles are congruent. Furthermore, we have this proof from earlier. These angles actually have to add up to 180 degrees. That's right. These angles together have to add up to 180 degrees. Did you catch that? These angles have to add up to 180 degrees. They are same side interior angles. And then last of all, the diagonals bisect. The diagonals bisect each other. So this diagonal is not the same length as this one, but they definitely meet in the middle. Okay, special types of parallelograms then. A special type of parallelogram, well, there are two. There are rectangles, which are a friendly rectangle. Not going to say too much more about those. The one thing I will say, these two things, all angles are congruent because all of the angles are 90 degrees. And then the diagonals are congruent because that line is the same as that line. That's actually something that's true of an isosceles trapezoid. Like maybe there's a connection between those two. Okay, now the other one's a rhombus, and a rhombus is a diamond, or from other times you've talked about shapes. And in a rhombus, all sides are congruent. But what's true about a rhombus is that the diagonals are perpendicular. There are two pairs of adjoining sides. The opposite sides are congruent. The opposite angles are congruent. And the diagonals bisect each other. Really what I'm saying is all of these things, whatever they're connected to, are also characteristics of a rhombus. And that leads us to the conclusion, well, what if you put all of the shapes characteristics together? What if we had the most restrictive shape of quadrilaterals possible, and it's a square. Because in a square, all sides are congruent. In the square, the diagonals are congruent. In a square, the angles are congruent in that they're 90. In a square, the diagonals bisect and the opposite angles are congruent, and the opposite sides are congruent, and the diagonals are congruent, and there are two pairs of adjacent congruent sides, and the diagonals are perpendicular. In fact, in a square, there's at least one pair of parallel sides. In fact, there are both. And also in a square, there are four sides, and there are two diagonals. So a square actually has all of these criteria as you look at the flowchart. Let's go ahead and answer some questions on the other page. And so I'm going to encourage you to see what I wrote and pause what I wrote, and then resume the video forward. Okay, page 400 is where this question was being asked. How can you determine which property to glue within each category? Well, kind of what I just said. By looking at the properties for sides, angles, and diagonals, I looked at where a statement made one class of shapes, like rectangles, more specific than another one, like parallelograms. So flipping back to this page right here, so looking at parallelograms and rectangles, in a parallelogram, all angles are not congruent. So I can't put this sticker with parallelograms. And the diagonals are congruent. I can't put the diagonals congruent with parallelograms. But all of these criteria of the parallelogram, opposite sides, opposite angles, and the diagonals, those are all characteristics of both of those. So whatever's a characteristic of both, put it on the top shape. Like four sides and two diagonals is the most basic description of all quadrilaterals, so it gets to go all the way up here at the top. All right. If one statement applied to every shape, like four sides, then I put it as far up the page as I possibly could. Is there a property associated with each category? Well, yeah, but also no. Like, look at squares. The properties of squares, well, actually, there are no specific properties only to squares, because squares get all the properties from up above. So I guess technically all of the properties listed apply to squares too. So there are no properties that are associated with just one. They're all associated with squares, like in general. This is page 400. This has been page 400. Thank you for watching this video. Page 401 is next. Click forward to that video and see you next video. Like, comment, and subscribe. Okay, bye.